Welcome, everyone. Today, we are diving deep into one of the most fundamental ideas in all of math, the language of sets. Whether this is your very first look at this stuff or you just need a really good refresher, you are in exactly the right place. Let's get into it. And hey, I want to give a huge, heartfelt shout out to all the incredible students over at Romblon State University. We put this explainer together especially for you to help you absolutely crush your studies. It is so great to have you with us. So, here's our game plan for today. First, we'll explore the world of sets. Then, we'll figure out how to size them up. After that, we'll see how different sets can relate to each other. And to wrap it all up, I've got a challenge for you that connects all this to your everyday life. Let's jump right in. All right, section 1. First things first. Before we can build anything cool, we need to understand our basic building blocks. So, what exactly is a set? Okay, so a set is just a well-defined collection of distinct objects. Now, those words are important. Well-defined means we can tell for sure if something belongs in the set or not. No gray areas. And distinct means no repeats. Every single item inside a set, which we call an element, is unique. Let's make this real. Picture a fruit basket. If our set, let's call it A, is apple, banana, orange, it's well-defined because we know a pencil doesn't belong in there, right? And it's distinct because we have one apple, one banana, and one orange. See? Simple. Now let's get into some special types of sets. First step, the unit set. You might also hear it called a singleton set. And just like the name suggests, this is a set with, you guessed it, exactly one element. It's the smallest possible set you can have that isn't empty. For example, the set U equals 5. It only contains one thing, the number 5. Now here's a key idea. Notice it's not just the number 5 itself, it's a set that's holding only the number 5. That little difference is actually super important in math. So, what's the opposite of a set with one thing? A set with nothing. We call this the empty set, or the null set. It's the one-of-a-kind set that contains absolutely zero elements. We show it with this special symbol, or sometimes just with empty curly braces. It's basically how we talk about nothing in the world of sets. So how does an empty set even happen? Well, think about this. Let's define a set P as all positive numbers that are also less than 0. Go ahead, try to think of one. You can't, right? It's impossible. And because of that logical contradiction, we know for a fact that set P has to be empty. Awesome, so we know what sets are. Now, let's figure out how to talk about their size. This brings us to a big question. Are we talking about a handful of elements or a never-ending amount? And that brings us to two major categories. You've got your finite sets. A finite set is one where you could, at least in theory, count every single element and eventually get to the end. But an infinite set? Oh, that one just goes on and on and on. If you tried to count its elements, you'd literally be counting forever. So, how do we get all official about a set's size? We use something called its cardinal number, or its cardinality. It's just a fancy term for the number of distinct elements inside the set. And we write it with these two little vertical bars around the set's name, like you see here. Okay, let's go back to our trusty fruit basket. We have our set S equals apple, banana, orange. So what do you think its cardinality is? I mean, how many different fruits are in there? 3. That's it. The cardinality of S, or S, is 3. For finite sets, it really is that straightforward. You just count them up. Okay, so we can define sets, we can measure them. Now for the really cool part. How do sets interact with each other? This is where these simple ideas start becoming incredibly powerful tools for solving problems. Now lean in for this one, because this trips a lot of people up. Equal sets have the exact same elements. The order they're written in doesn't matter, but the stuff inside has to be identical. Equivalent sets, on the other hand, just need to have the same number of elements. The things inside can be totally different. So here's the key. Equal is about what's inside. Equivalent is about how many things are inside. Next up, do our sets overlap? If two sets share at least one element, we call them joint sets. But if they have absolutely nothing in common, like their worlds are completely separate, we call them disjoint sets. It's really just a simple question of, do they share anything? Yes or no? Okay, let's zoom all the way out to the big picture. The universal set, which we usually write as a capital U, is basically the set of everything we're interested in for a particular problem. It's the whole universe of options that we're allowed to choose from. For instance, if we're having a conversation and the only topic is numbers from 1 to 100, then our universal set is all the whole numbers from 1 all the way up to 100. Any other set we create, like say the set of even numbers, would have to be pulled from that specific universe.
Whew, we have covered a ton of ground, from single item sets all the way to the whole universe. So for our last section, let's take all this new knowledge and see how it works in the real world.
You ready for a lightning round recap? Let's do it. A unit set has 1 element. Empty set has 0. Finite sets are countable. Infinite sets are uncountable. Cardinality is the count. The universal set is the big picture. Equal sets have the same stuff. Equivalent sets have the same amount of stuff. Joint sets share and disjoint sets don't. Got it? Awesome. And now here is your challenge. I want you to look around you right now. Can you find examples of these sets? Maybe the set of books on your shelf is a finite set. Maybe the set of people in your family and the set of characters in your favorite TV show are disjoint sets. Start looking for the language of math all around you. Listen, you absolutely have what it takes to master all of these concepts. Think of math as a language, and you're learning the grammar right now. Keep that curiosity going and just keep exploring. You've got this. And finally, if this explainer helped you out today, please consider supporting our class channel, No Problem, Only Solution. When you hit that like and subscribe button, you help us create even more explainers just like this one to help you succeed in mathematics in the modern world. Thanks so much for joining us, and we'll see you in the next one.